Hi, I'm Sunnie, and I'm a PhD student at Princeton University, and I'll give an overview of our paper, HIVE, Evaluating the Human Interpretability of Visual Explanations, done with Nicole Meister, Vikram Ramaswamy, Ruth Fong, and Olga Russakovsky. Our work was motivated by a lack of standardized evaluation frameworks for interpretability methods. With tens and hundreds of new methods being proposed each year, and with these methods becoming more diverse in terms of their goals and forms, we argued that it is more important than ever to have a standardized framework for interpretability evaluation. To this end, we developed HIVE, a human evaluation framework for visual interpretability methods designed with three principles in mind. First, we wanted to move away from intuition-based justification and towards evaluation that allows for falsifiable hypothesis testing. Second, we wanted to complement existing algorithmic evaluation metrics with the human-centered evaluation framework. And finally, we wanted to go beyond evaluation methods that only apply to one type of method and enable broader cross-method comparison. In summary, we make the following contributions in our work. First, we present and analyze a new human study design and demonstrate its effectiveness and usefulness for evaluating four distinct interpretability methods. Second, we investigate the utility of visual explanations in distinguishing correct and incorrect model predictions. We also conduct the first human studies for interpretable by design models and study how people trade off interpretability and accuracy. Finally, we open source HIVE to enable future studies and encourage more human-centered approaches to interpretability research. Here's an overview of the HIVE study design. We developed two objective evaluation tasks that measure whether explanations can help users distinguish between correct and incorrect model predictions, which we consider a crucial property for AI-assisted decision-making. Concretely, we have the agreement task that measures how much confidence explanations instill in the model's predictions, and the distinction task, which measures how well people can identify the correct prediction out of multiple options based on the provided explanations. To evaluate interpretability methods with very different forms on a common task, we created an individual evaluation UI that respects each method's characteristics, such as its explanation form or dataset used for model training. Here as examples, we show the UIs for evaluating ProtoPNet on the agreement task and GradCAM on the distinction task. Using HIVE, we conducted IRB-approved studies with 950 participants and evaluated four methods that span the diversity of visual interpretability methods. These are GradCAM, a popular post-hoc explanation method that generates heat map explanations, BagNet, an interpretable by design model that generates heat map explanations, ProtoPNet, an interpretable by design model that generates prototype-based explanations, and finally, ProtoTree, an interpretable by design decision tree model that generates prototype-based explanations. Through our experiments, we find the following. First, our agreement task results show that participants tend to believe that a model prediction is correct when given an explanation for it, revealing an issue of confirmation bias. Second, our distinction task results reveal that participants struggle to identify the correct prediction based on explanations, suggesting that interpretability methods should improve their ability to identify and explain model errors. And finally, our interpretability accuracy trade-off results show that participants prefer a model with explanations over a baseline model that doesn't come with any explanation, and more so in higher risk settings. Here's a summary slide with a link to our project page where you can find more information about our work. Thank you.